Hello students, welcome back to engineering geology classes. In the previous class we had discussed what is mean by physical weathering. Now we'll discuss what is mean by chemical weathering. So chemical, as the word tells you that it is a chemical phenomena or chemical reactions are involved in it, and they break the rock, so we call it as a chemical weathering. So what is the definition of chemical weathering we will discuss. So it is a process of alteration of minerals whereby the primary minerals they are converted into the new compounds, that is called as the chemical weathering. So what happens in chemical weathering? It is a process, natural process of alteration of minerals, because we know the rocks are made up of mineral. Rock is an aggregate of minerals, so the minerals which are present in the rock, they convert into new compounds, and here water plays a very important role. So water is the main agent in the process of chemical weathering. Because it brings about the changes in the composition of the rock material by decomposition of the rock. So rocks will undergo decomposition by the chemical process. So we had seen the definition of weathering. It is physical breakdown and chemical decomposition of the rock. So here the rocks will undergo decomposition as a result of chemical reactions taking place there. Okay, so that is called as the chemical weathering. It brings about the changes in the composition of the rock material by decomposition. So here in the image you can see there is a cave. Okay, inside the cave you can see the stalactites and stalagmites. Okay, so how these are formed? The hanging mineral that is usually seen in the limestone caves. Okay, this can be seen in Ulvi, okay, which is very near Dandeli. Okay, there you can see these type of hanging structures, that is stalactites and stalagmites we call. So these are formed by again the chemical reaction. Okay, the reaction with water and the rock. Then reaction with oxygen leads to corrosion, right? Then reaction with acids lead to formation of such sinkholes, because like this caves are formed inside by reaction of water and the rock, and the support from the bottom is removed, and as a result the ground will sink. So we call such holes as sinkholes. Okay, then reaction with oxygen, all these we will discuss in detail. So there are different chemical processes which are in the rock decomposition. They are, the first is hydration and hydrolysis, then carbonation and oxidation. So these are the chief chemical processes which take place on the rock, and the rock starts decomposing. So we will see one by one what it means. So first we will discuss what is mean by hydration. So the name itself tells you that there is a water involved in it. Hydration means water. So hydration is a process by which certain minerals, like here in the reaction I have given example of Fe2O3, that is hematite, which is iron ore. This hematite, okay, this absorbs the water, or it will react with the water to produce the new mineral, that is the this complete is the new mineral, that is the limonite. So what happens in hydration? Hydration is a process by which certain mineral absorb the water or react with the water to produce the new mineral. In short, what? Addition of water molecule. Here you can see Fe2O3 plus 3H2O gives rise to Fe2O3.3H2O. So here addition of water molecule has taken place. So that is called as the hydration. One more example is anhydrite. that is CaSO4 calcium sulfate plus 2H2O. This gives rise to again addition of water molecule CaSO4 dot 2H2O. So this is one more example wherein anhydrite, that is calcium sulfate, it reacts with water and it converts to gypsum. So this end product is a gypsum. So this chemical reaction takes place in hydration. Then next is hydrolysis. So what is mean by hydrolysis? So here this process involves exchange of water ions. Here water can be splitted as, that is H2O. You can write it as H plus and OH minus, right? So H plus and OH minus, it will split. So the process involving exchange of water ions, that is called as hydrolysis. So it is a chemical reaction between the hydrogen, that is H plus, and the hydroxyl, that is OH minus, ions of water and the minerals, okay, the mineral ions which are present. So hydrogen, that is H plus ions, it actually replaces the positive ion in the mineral. So here in the reaction you can see this is a feldspar, that is KAlSi3O8, that is a feldspar. When it reacts with the water, that is H plus and OH minus, you can see here H plus and OH minus has splitted and it has combined with the mineral, giving rise to new mineral, that is KOH is a soluble salt, then HAlSiO4 is a clay, okay, and this is a silica or quartz. So this is 2SiO2. So this is what happens in hydrolysis, splitting of the ions. So exchange of ions, you can say. This process involves exchange of water ions called hydrolysis, H plus and OH minus. So this is called as hydrolysis. So this is the first process of chemical decomposition or chemical weathering, that is hydration and hydrolysis. Next process we will discuss, that is carbonation. So what is that carbonation? So here the main the rainwater, what is falling in the form of precipitation, okay, we call it that the rainfall is also called as precipitation. So this rainwater, it combines with CO2, plus the rainwater, that is H2O. So this gives rise to carbonic acid. So carbonic acid, this H2O plus CO2, it combines and it forms the carbonic acid, that is HCO3. Okay, so this is the carbonic acid. So here water plus CO2 gives rise to carbonic acid. And suppose this is a mineral called calcite, CaCO3, that is calcium carbonate. So calcium carbonate, that is CaCO3, okay, and the carbonic acid, which is formed by combining H2O and CO2. So this gives rise to HCO3, that is carbonic acid. So this acid, that is carbonic acid, it reacts with the various elements such as calcium, magnesium, iron, which are present in the mineral, and it will transform them into carbonates and bicarbonates. So this process is known as carbonation. So the resulting products, they are carried away in solution, and the carbonate rocks are more susceptible to this process, like the limestone, whose composition is calcium carbonate, CaCO3. Okay, so calcite is a mineral and limestone is a rock. okay, which is made up of CaCO3. So here CaCO3 plus carbonic acid, that gives rise to calcium bicarbonate. So that is CaHCO3 twice, okay, that is calcium bicarbonate. So the temperature factor also plays a very important role in this particular process, that is called as carbonation. So what happens in carbonation? The rainwater combines with CO2 to form carbonic acid, and this acid reacts with the various elements such as calcium, magnesium, iron in the minerals, and transform them into carbonates and bicarbonates. So that is called as carbonation. Next is oxidation. So what is mean by oxidation? So here you might, best example to understand oxidation is, as you can see in the image, the rusting, right? Rusting of iron, you all have seen, right? The old nails or the bars, they undergo rusting. Why? Because they react with the oxygen, that is oxidation. So here what happens? It is a process of combination of oxygen, okay, oxidation means oxygen will combine, that is O2, with the other elements, that is known as oxidation. So what is that? The process of combination of oxygen, that is O2, with the other elements, that is known as oxidation. So this process involves what? The alteration of the minerals with the production of oxides, okay. Then the resulting products of oxidation, they show brown or yellowish material coating to the surface of the rock. So this type of brownish or reddish color coating, you can see yellowish color coating on the surface of the rock. So many sedimentary rocks which contain iron, okay, so the rocks such as sand, sandstones, clay, which have inclusion of ferromagnesium. Ferromagnesium is which contains iron and magnesium, that is Mg. So such minerals, they often show brown coloration, indicating that the minerals have undergone oxidation and it turns into oxide. So limestone and hematite, they are very common products of oxidation, which imparts the red and yellow color to the soil. So these are the this is called as oxidation, wherein reaction with oxygen and the mineral takes place. So one more thing I would like to tell regarding the previous process, that is carbonation. So carbonation, that is, I told you that it forms carbonic acid, which is nothing but the acid rain. You might be aware of acid rain. And our Taj Mahal, that is constructed in the rock which contain calcium carbonate, that is marble, right? So when limestone undergoes metamorphism, okay, it forms the marble. So this marble is a metamorphic rock, but its composition is again CaCO3. So this acid rain, what takes place, that is by combining the water and CO2, that is carbon dioxide. So this acid rain will react and it forms the calcium bicarbonate. So it is nowadays showing the Taj Mahal is showing the some effects, adverse effect of the yellowish coloration on the surface. So that is because of the acid rain, okay, and the reaction with the marble. So this is what carbonation and oxidation. Okay, then one more category you can separate it out. Actually it is a physical weathering, but you can call it as a biological weathering because the plants and animals are involved in the process. So they are categorized as biological weathering. So what is mean by that biological weathering? Wherein the roots of the plants or the animals, okay, they accomplish a considerable amount of rock disintegration. So this is a part of physical weathering, not the chemical weathering, because here the physical forces are acting on the rock and the rock is breaking. So plants and animals, they accomplish the considerable amount of rock disintegration directly or indirectly, they are responsible. So these growing plant roots, as you can see here, here and here, right? So they exert what? The powerful pressure on the walls of the rock fracture. So wherever there are cracks, the roots have penetrated and they have exerted pressure, and that pressure will cause the crack to widen, okay. So that the roots will exert pressure on the cracks or the walls of the rock, and the rocks are wedged apart or they are broken apart. So the mosses and lichens on the surface of the rock, they also lose the mineral grains, right? And the burrowing animals, like this, the burrowing animals, then the burrowing animals and such as earthworms, ants, then rodents, they also contribute to the disintegration of the rocks. And even the human beings are also responsible for weathering directly or indirectly. Like we perform various activities like mining, tunneling, road cutting, coring, and other activities which help the process of disintegration. So this is how the man is also responsible for the weathering. So these are the different processes which are involved in the physical and chemical weathering. So if you talk about the physical weathering, what are the favorable factors? They are the cold and dry climate, fractured rocks, and inclined or steep surfaces of the rock. They are the main favorable conditions for physical weathering. Then for chemical weathering, what are the factors which are favorable for the decomposition of rock? They are the warm and humid climate, low-lying areas, then rock containing the chemically reactive minerals like calcium, magnesium, sodium, iron. So they are more susceptible to the chemical weathering. So if the rock contains such minerals, they are more susceptible for chemical weathering. Now we'll see what are the products of weathering. So the ultimate end product of weathering, they consist of three parts. One is the unaltered rock fragments and durable resistant minerals are formed, okay, as an end product. And sometimes the insoluble products of the rock decomposition are also formed, and some soluble salts are also formed as a result of weathering. So soluble salts, they quickly leach away and they are transported by groundwater into the streams, or finally they reach into the sea. Then the other two, that is the materials which remain behind and accumulate in the soil, that is the regolith is the upper layer of the soil, so that they accumulate into the soil. The unaltered rock fragments and the insoluble products, okay. So the nature of these products and their composition, it depends upon the composition of the original rock which has undergone decomposition, right? And the type of weathering, which in turn depends upon the climatic conditions. So which weathering takes place in which area, it depends upon the climatic conditions also. So these are the products of weathering. Then now we'll discuss one important point, that is why what is the engineering consideration of weathering. That is very very important. Being a civil engineering or being a civil engineer, you must know what is the importance of this weathering. So engineering projects, they are built up on the soil, as we all know, right, or on the rock, right? So the soil is what? It is the ultimate end product of weathering. End product of weathering is soil. So the when you lay the foundation, you have to carry down to till you get the hard rock or the bedrock, as in case of heavy constructions like dams, tunnels. Okay, so the trend of weathering in a area, that will be very very important guiding factor for you, right? The building made of any stone or the brick or the concrete, they are susceptible to some type of weathering, okay, and when they are exposed to the rock surface or weathering. So also the monuments, statues, then ornamental stonework, whatever is done, they can be badly damaged by the natural weathering processes. So this is accelerated in areas which are severely affected by acid rain, like Delhi and all, where pollution is more, acid rain is more, there the rocks are more affected. Then for construction engineer, it is always necessary to see that what is the extent of weathering, to what extent the area has undergone weathering, or the area under consideration for a proposed project that is affected by weathering, and what may be the possible effect of that weathering process on the construction materials also. What construction material you are using and what effect it will have on the construction material, that also you need to take care when you deal with any type of project. So ultimately it depends upon the climatic condition and the type of rock or the type of material. So it may be necessary for a dam or a tunnel or any type of construction to remove the loose and weathered material which is at the top, okay, and you have to carry the foundation till you get the hard, solid, sound rock. Okay, for construction engineers, it is very very important to determine the behavior of the rocks like marble, limestone, granite towards the environment of that particular area. So this is very very important to know the type of rock, type of area in which you are constructing, and what may be the possible effect of that weathering on the construction material as well as on the rocks on which you are constructing your structure. So with this weathering, which is a very 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 important chapter from geology, engineering geology, so this will be often asked in the exam. So all the both physical and chemical weathering, they may ask you, or they may ask you physical or chemical weathering separately. So you have to prepare both the questions, which is very very important from exam point of view. Thank you.